Okay, so this first S1 exam, March 2021. Let's look at the questions. It says a pair spinner with 5 sides numbered 1, 2, 3, 4, 5 is spun repeatedly. The score on each spin is the number on the side on which the spinner lands. Okay, when it says repeatedly, that means there are an infinite number of trials. Therefore, this is what we call a geometric progression. Geometric distribution. Sorry, not progression. Okay, it says find the probability that a score of 3 is obtained for the first time on this 8th spin. Okay, when it is a first spinner, having a score of 3 has the probability 1/5, and I'm looking for the 8th turn. So q power r minus 1, p power 1, 4/5 power 7, 1/5. Okay. That gives me 0.0419. Okay, then it says find the probability that fewer than 6 spins are required to obtain a score of 3 for the first time. So fewer than 6 means x less than 6. We don't have a formula for less than, but we do have a formula for less than or equals to. So less than 6 can be written as less than or equals to 5. And I can simply say that this then becomes 1 minus q power r, which is 1 minus 0.8, which is 4/5 basically, power 5. That's the formula for less than or equals to. Yeah, 0.672. Okay. That was a simple question on geometric progressions, geometric distributions. The next one is probably about probability. This looks like something that I should draw a tree diagram on. Let's see what the question says. Georgie has a red scarf, a blue scarf, and a yellow scarf. Each day she wears exactly one of these scarves. The probability for the colors are 0.2, 0.45, and 0.35 respectively. When she wears a red scarf, she always wears a hat. When she wears a blue scarf, she wears a hat with probability 0.4. When she wears a yellow scarf, she wears a hat with probability 0.3. It's best that I draw a small tree diagram because I know that there are multiple parts to this question and it's going to be useful if I have a tree diagram right in front of me. Okay. Red, blue, and yellow. 0.2, 0.45, 0.35. When she wears a red scarf, she always wears a hat. So there's only one possible outcome here, which is H, and it has a probability 1. When she wears a blue scarf, she has a probability of wearing a hat. With 0.4, 0.6. 0.3 and 0.7. Now, I always ask you to write down the outcomes of each of the branches. So this is R and H. This is B and H. This is B and H naught. This is Y and H. This is Y and H naught. Now I want to find out the probability that a randomly chosen day, Georgie wears a hat. So the outcomes RH, BH, and YH are all relevant. So I'm going to say 0.2 into 1 plus 0.45 into 4, 0.4 plus 0.35 into 0.3. That gives me 0.485. That's the probability of wearing a hat. So it says find the probability on a randomly chosen day, Georgie wears a yellow scarf. Given that, when it is given that, what I'm trying to calculate is a conditional probability given H naught and that she wears a yellow scarf. Okay, so the denominator will have the probability of H naught. Now, H naught can simply be calculated by subtracting H from 1. So the denominator becomes 1 minus 0.485. The numerator is the branch that has Y and H naught. So Y and H naught is this branch. So I'm going to say 0.35 into 0.7. That gives me 49 over 103, which is 0.476. Yes, that's the correct answer. Then question number 3 says the time spent by shoppers in a large center has a normal distribution with mean 96 and standard deviation 18. Find the probability that a randomly chosen shopper spends between 85 and 100 minutes. So I'm going to convert to Z on both sides. This becomes minus 0.611. And 0.222. So this becomes 5.222 minus 5.611. And I have 1 minus 5.611. I need to read these two from the table that I have. Point 611 is 7291 plus 3, so 7294. Point 222. 0.5879. Point 5879 minus 1 minus 0.729. That gives me 0.3173, which is 0.317. Okay. Then it says 88% of the shoppers spend more than T minutes. So the probability of X greater than T is 0.88. Again, I'm going to convert this to Z. 96/18. So it becomes 1 minus phi of t minus 96/18. I shuffle things around. Okay, since I can't read this from the table right now, what I'm going to do is I'm going to introduce a minus and I'm going to subtract from 1 inside. So I'm basically reading a negative value from the table for 0.88. Now the probability of 0.88 is the z value for 0.88 is 8790 and should be plus 10. So I'm going to get 1.17 and 5. 1.175. So let me verify that. Yes, that's the correct number with the negative outside. So therefore t becomes what? 74.85. Rounded off to 3 significant figures gives me 74.9. So that was normal distribution. And it says the random variable x takes the value 1, 2, 3, 4. This is about probability distributions. It can take on the value 1, 2, 3, 4. So I'm going to draw a table that has x values from 1, 2, 3, and 4. Okay, in order to calculate x equals to 1, what I'm going to simply do is use this function. K times 1, 5 minus 1 gives me 4k. Similarly, 2 is k times 2, 5 minus 2. That gives me 6k. With 3, that also becomes 6k. And with 4, it becomes 4k. So I have the entire table in terms of k. Let's verify if that is the correct. 4k, 6k, yes. It says show that the variance of x equals to 1.05. So I'm going to first need the value of k. So I'm going to say that all these k's add up to 1. .05. And when I need the variance, the formula for variance is sum of x squared p of x minus the expectation of x squared. So in order to calculate this, I'm going to say that my probability distribution table looks something like this now. In order to avoid all those calculations within the formula, just drawing up a table. 4 into 0.05 gives me 0.2. This is also 0.2. 6 into 0.05 gives me 0.3. This is also 0.3. So this becomes 1 square into 0.2 plus 2 square into 0.2 plus, 0.3 plus 3 square into 0.3 and 4 square into 0.4. For the expectation, again, I'm going to have to do some working since I haven't calculated the expectation before. It's simply the value of x into the probability of x, and then the sum of those numbers. Okay, so 1 into 0.2 plus 4 into 0.3 plus 9 into 0.3 plus 16 into 0.4 minus, let's write that. That's 21 over 2. And 0.2 plus 0.6 plus 0.9 plus 0.8. 5 over 2 squared. .25. And I'm still made a mistake somewhere. Where is my mistake? A small error when writing this. Give me the wrong answer. That's correct. Okay. Then says the driver records the distance in each of the 150 journeys. These distances correct to the nearest kilometers are summarized in the following table. Draw a cumulative frequency graph to illustrate. Okay. In order to draw this graph, what I need to do first is make sure these classes are continuous or connected. Okay. So I'm going to introduce new boundaries. This is the average of 4 and 5. This is the average of 10 and 11. And so on. Okay. Then I'm going to calculate the CF. So this is 12. 12 plus 16 gives me 28. Plus 32 gives me 60. Plus 66 gives me 126, 146, and 150. Now, when I'm drawing my cumulative frequency curve, I need to take the boundaries up to 60.5. So okay, that seems like a reasonable way to do it. Let me just draw this. So this is 0. This is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. The cumulative frequency goes up to 150. So I think I will have to do this 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 150. This is CF, and this is what? This is distance. Let's label this distance. Now, in order to plot these, the first thing that I have to plot is 4.5 and 12. So plotting 4.5 and 12. Okay, that's not 12. This is 12. That's my first point. Then I have 10.5 and 28. And 28. Then I have 20.5 and 60. Then 30.5 and 126. 30.5 and 126. Okay, then I have 40.5 and 146. And then I have 60.5 and 150. 60.5 and 50. Okay. Then I'm going to draw the graph as smooth as I can. The trick is to not lift your hand from the paper. Okay, this is as smooth as possible. Although I think it's slightly. Just need to make sure I've plotted the points correctly. This is accurate as I think I can draw it. Okay, let's verify if we've drawn it correctly. Those are the points that need to be plotted. I think we've got them all correct. There's a slight wave here, so that means I'm drawing it correctly. Okay. Let's move on. Then it says for 30% of these journeys, the distance traveled is d kilometers or more. So what I'm asking you is 30% of the total. The first thing that I want to do is 30% of 150, which is 45. Now, always decide whether you want to have the top 45 or the bottom 45. Since it says d kilometers or more, I'm talking about the top 45. Now, when I subtract 45 from 150, I get 105. So what I'm going to do is I'm going to take my pencil and read 105 from here. And this turns out to be approximately 27. So D is therefore 27. Is that the correct answer? Approximately 27, which means my curve was also correct. Then it says calculate an estimate of the mean distance traveled for the 150 journeys. Okay, I want to calculate the mean of the 150 journeys. So what I'm going to do is I'm going to write my table again. Okay, because I need some space. Now, what I'm going to do is I'm going to write my adjusted table. These are the classes that I have now, 10.5 to 20.5. 20.5 to 30.5. Now I have not adjusted the first class, that is 0, because distances cannot be less than 0. .5 to 60.5. Now this is the class 12, 16, 32, 66, 20, and 4. 12, 16, 32, 66, 20, and 4. So that's the column for frequency. Those are the classes. The formula for mean is sum of fx over sum of f. So what I'm going to need is I'm going to need all the midpoints of the classes. So I'm going to create a new column called midpoints. And the midpoint of 0 and 4.5 is 2.25. Then 4.5 and 10.5 give me 7.5. And then I have 15.5. That's 51. So that's 25.5. That's 35.5. 50.5. I'm then going to apply the formula fx 12 into 2.25 plus 16 into 7.5 plus 32 into 15.5 plus 66 into 25.5 plus 20 into 35.5 plus 4 into 50.5. And I know that I have a total of 150 observations. So I'm going to just divide by 150. Let me just verify the numbers. 3238. Okay. 21.6. Okay. And this question is about permutations. It says find a total number of different arrangements of the 11 words in the word caterpillar. Okay. So that's 11 factorial, and the repetitions. So 2 factorial, 2 factorial, and 2 factorial. Okay. Then it says, let me just calculate that. What do I get? Four, 9, 8, 9, 6, 0, 0. Okay, find the total number of different arrangements of the 11 words in the word caterpillar in which there is an R at the beginning and there is an R at the end, and the two A's are not together. So what I could do is I could find the total number of arrangements with A's together and then subtract them. Or I could also do this, that I could say that leaving out the A's and putting out the R's, I have 1, 2, 3, 4, 5, 6, and 7 letters. So I'm going to say that there are 7 letters here. So I'm going to say 7 factorial divided by 2 factorial because there are 2 L's involved. Then A's could appear in any of these positions. How many positions? There are 8 positions. So I'm going to say that A's are going to come in 2 of these positions, arrange themselves, but since they're identical, I also want to divide. So I get 7 factorial over 2 factorial into 8C2, 70560. Yes, that's the correct answer. 70560. The marking scheme would tell you alternates, where you can sort of put A at the end, A at the start, and then I can't scroll this. Okay. It says find the total number of different selections of the 6 letters from the 11 letters. So let me just bring the 11 letters down. In fact, I'm going to write that again. Caterpillar. Okay, I need to select 11 letters that contain both R's. So R's you are compelled to take, and at least one A and at least one L. So there could be one A, one L, and then you could have 2 different letters. Okay. So I'm going to say that the first case that you could have is 1, 2, 3, 4, 5. I could take 2 more letters and say that this is 5C2. Then I could have 2 R's, 2 A's, 1 L, and 5C1. Then I could have 2 A's, 2 L's. Okay, that would be just 5C0, which is 1. This is 5. This is 10. Then I could have another case where I have 1 A, I have 2 L's, and I have 5C1. I get 5. That's a total of 21 different combinations. I don't know why I can't open this bit. Okay, that's the correct answer. Then the last question on this exam is there are 400 students at a school in a certain country. Each student was asked whether they preferred swimming, cycling, or running, and the results are given in the following table. I know from experience that whenever I have a table like this, it's wise to first calculate the totals because I'm probably going to need all of them. So I have 220 here. And I have 31, so that's 180 here. And that's 135 here. That's 107 here. And 66 plus 92 is 158. So I have a total of 400 in both cases. It says a student is chosen at random, find the probability that the student prefers swimming. So out of 400, how many prefer swimming? 135 prefer swimming. That's simple. Determine whether the student is male and the student prefers swimming or independent. So what I'm going to need is I'm going to need M and S, and I'm going to need probability of M into probability of S. If these two things are equal, I'm going to say that they are independent. Otherwise, they are not independent. 180 divided by 400 and 135 divided by 400. M and S, so that's 31 people. 31 divided by 400. Let's check if both these sides are equal. This gives me 0.0775. And this gives me 0.152. They're not equal, therefore not independent. Okay, I have the right numbers. Then it says on average, out of all schools in the country, 30% of the students do not like any sports. Okay. 10 of the students from the country are chosen. Find the probability that at least 3 of them. This is a question on binomial distributions. I have a probability of success, which is 0.3. And when I say at least 3, I'm trying to find this probability. How can I calculate at least 3? By subtracting 0, 1, and 2 from 1. So this becomes 1 minus 10C0, 0.7, 10 minus 0, 0.3 power 0. 10C1. I'm going to do these calculations on my calculator, and I'm going to tell you the final answer because I have the ClassWiz calculator and that can help you calculate very quickly. There are some videos on my YouTube that will help you use your calculator well. Point 6172. Yes, that's the correct answer. It says 90 students are chosen. And it says use a suitable approximation. So this question is about converting the binomial to a normal distribution. Okay, when I convert to a normal distribution, I need mu and sigma. So 90 into 0.3 gives me 27. And sigma square is 90 into 0.3 into 0.7. One thing that you should also always remember when you're doing questions on conversions is to do continuity correction. So the continuity correction for this would be x is less than 31.5. So I get 31.5 minus 27 divided by 1.035, 1.08497. 8497. Okay, 8497 gives me approximately 0.85. Okay, that's the exam for today. I'm going to solve the other paper in the next class, not today. I have some work to get back to. I'm going to solve that in the next class. That's it for today. Thank you.